Hello, this is Mr. Bean. Welcome back to another lesson in pre-calculus. Today we're talking about extrema and function analysis. Now real quick, extrema, what in the world is that? Extrema is a plural way of talking about when you have max and mins. And so when you have something like this, we're talking about a maximum point or a minimum point. That's what extrema are. So it's basically just a short way of talking about both maximums and minimums, or maxima and minima, depending on how you want to say that. Okay, that's what extrema are, and we're going to focus on that. And then we'll get into something with function analysis. Now, to give you an example of things that are extreme, on one end you'll have somebody who's really cool, and then on the other end you have somebody who's just I don't even know how to describe that. Extremely just crazy. And then you have, of course, extremely handsome, and then extremely kind of creepy. I don't even, again, kind of here. Let's fix that. Extreme. Here, Mr. Bress, we're gonna show up people there. We're gonna show up. You're gonna look like in just a couple of years here, maybe. Like that. Okay, so jumping into our lesson, we're gonna start off with the definition of an absolute max or min. An absolute max or min is absolutely the highest or lowest point, meaning it is higher than anything else that's on the graph. So this here would be, for our example, an absolute maximum point because it is higher than anything else you can find. There is no absolute minimum on this graph because it goes down forever and ever. So that is a max or min, that is an absolute. Now a relative, or another word for relative, you may want to add this to your notes. You could also call this a local. You'll see that a lot of times in textbooks, or teachers will refer to it as a local max or min. In fact, you'll probably hear me say that during the lesson too. That is a point on the graph that is higher or lower than just the points that are right around it. So for example, here is a maximum point. It is an extrema. It is a relative or local maximum point because it is higher than the points that are right around it. This one here is another example of a local or relative minimum point because it is lower than the points that are right around it. That also means that an absolute max, this one that we did first here, it is an absolute and a local or relative. So it's both because it is relatively higher than all the other points around it, and it is absolutely higher than everything that's on this graph. So absolutes are also local. Now, we're looking into finding a max or min means that we're looking for the y value. Okay, so when you say what is the maximum value of a graph, you're actually, on this example, it would actually be about a 3.2 or so. The maximum value is a y value. Okay, we'll talk a little bit more about that in some other examples, but the x value just tells you where it is. The y value is actually the value of the max or min. Think of this as what's the highest point of the roller coaster. If you're talking about the highest point of the roller coaster, you'd be talking about the feet, how high up it is. You wouldn't be talking about how long it took to get there. For our first example, you're going to plug this big, long mess of an equation into your calculator. So go grab that if you don't have it yet. I'm going to pause here and plug this into my calculator as well so we can get this graph to show up. Here I have it plugged in. You can see this 0.05, x to the 6, and so forth. But if I graph it on a standard window, so a zoom 6 for a standard window, -10 to +10, you can see that it's not going to match up very nicely with what I have over here with the graph on your notes. So what we need to do is change our window. Now I have provided for you what the minimum and maximum should be for our window range. So if we go over here.
Let's see, I went over, it looks like about -5, -6, somewhere around there. Let's put -5. My x max, I went over here. Looks 2, 4, 6, 8. Looks like I went to 8. So we'll put an 8 there. And then x scale, if we want to make it look exactly like mine, I can do an x scale of 2, because I'm counting my 2s. And now my y min, look way down here, it looks like I'm about -70 or so. So -70, and my y maximum, 30. And what was my scale? I counted by 10s. Now this isn't necessary, the scale doesn't really matter to be able to calculate this stuff. I just wanted to graph something that would make it look like what we have there on our notes. Okay, perfect.
Boy, that looks good. Now, let's figure out all of the extrema and classify them. So the first step is, let's do second calculate. We'll calculate a minimum point.
3, and I think I'm going to, minimum point. And we need to scroll way over here, so you can just keep hitting left if you want. Hold that down, we'll move left, 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 left. As long as we're left of this minimum point, because that's the one I'm going to look for right now, then we can hit enter. And now go right of it, and we'll hit a right boundary on the right side of it. And guess just means if you wanted to get close, you can, but there's only one in between the boundary lines. And there's our minimum, -2.5. Let's drag that over here so I don't forget it. -2.5. So we have a local
we'll describe what it is, a local or relative, you call this relative, minimum at, and then the coordinate point is negative 2.583, comma, negative 41.337.
All right, there is my first minimum. Let's now find another one.
Second maximum, second calculate, let's find the maximum, number 4, left boundary, anywhere around here is good, and then let's go do my right boundary, and go past the maximum, hit enter, guess, and oh, there it is, there's my maximum point, so I have a maximum of, let's say a relative, they're the same thing, local, relative, same thing, relative max at, what is that, negative 5.284 e to the negative 7, that's just basically 0. Okay, it's so far close to 0 that we just count that as a 0. 0, comma, 1.
That's where my maximum is. Now, go ahead and pause the video now and just get this minimum on your own, and I'll have the answer appear here in just a sec. And there's our answer, but this time it's not a local or relative. It is called an absolute minimum at 4.168, negative 57.67. There is our answer. So I had the screenshot there. Now on the next part, when it says what is the minimum value of f, minimum, remember, when we're talking about the value of it, that's just asking for a y value. And so the answer to this one is just negative 57.67. That is a minimum value. It is the lowest possible value on the graph. On our next couple examples here, we're looking at finding the extrema when you're dealing with endpoints, and that can be a little bit tricky. This right here is considered a relative or local maximum. And so the reason it's a relative max is because this point is higher than all of the points that are right around it. Okay, so this is a little bit weird, but that is a relative max. And then, of course, this here would be a relative min if we were talking about the minimum value here. But just focusing on the endpoint, that's a relative max. But when we look at this one, this right here is nothing. It is not a relative min or a relative max. And that's sloppy. Sorry. The reason this is neither a relative min or max is because if we zoom in on this, and I'm going to try and see how good I can zoom in on this with my software. If we zoom in and zoom in and zoom in and get closer and closer, no matter how close you get, there's always going to be a point in between this open circle and the dot. We could just go in farther and further and further. Basically, you're going to get closer and closer decimal point to getting closer and closer to 2. Okay, yeah, I'm confusing myself there. Basically, open circle, there is not an actual point there. There is no extreme value because you're always getting closer to that. All right, so now what about something like this craziness? Down here, this bottom is still a relative minimum. This thing is nothing. We talked about that. But what about this? Well, you have to think about it. Is this higher or lower than the points that are all around it? Well, it is higher than the points that are right here. It is higher than the points directly to the left because the points directly to the left are way down here. And so this is considered a relative maximum because it's higher than the points that are right around it. It's not an absolute because the graph keeps going up forever and ever. So we have a relative max here at x equals 2 and a relative minimum at 1, negative 3 for these points. But it's a relative max at 2, 4, right? Yeah, 2, 4. Now let's grab a calculator again. We're going to do some practice with how do we look at getting things in a good window that you can see it. So grab that calculator and let's follow along. I'll get mine plugged in too. Okay, here I have it entered in my calculator and we're going to do a standard window. So let's just do a zoom 6. And you'll see here that we really can't see much of at all what's going on. I have this almost what looks like a vertical line. It's not vertical, but it sure is a steep line. And so I'm going to drag this over here so we can kind of see the progression of what we're going to do to fix this. One way you can start, if you have no idea, and I always like to just start on the zoom 6, the standard window, because then you'll know what you need to do from here. I also look at this y-intercept. When I see a 5,000, I want to be able to see the y-intercept in my screen. Me personally, I like the y-intercept right in the middle, and so I'm going to do this. Let's go to my window, and I'm going to set the maximum at double the y-intercept. Okay, let me say that again. I'm doubling the y-intercept. 5,000 is the y-intercept, so let's go 10,000. That way I can see it right in the middle. Nothing else needs to change. I don't need to change my x-min and x-max A lot of times students will they'll put in a 10,000 here, and it's like, whoa, that is way too big. You don't need to go that far on x's. But y's, sometimes you do. So let's graph this and see what we've got. And okay, this is pretty good. That helps us a lot more. We can kind of see some things that are going on. So let's drag this one. We're going to keep looking at what my progression is as we're getting better screens. And now we want to know if there's, it is cubic. So I know on the left side it's going up, on the right side it's going down here. But what about right in here? It doesn't look like we have any mins or maxes, but I need to double check for sure. There's a couple ways of doing this. One, you could just change the window, the min and max, so that the y min is closer to 5,000 and the y max is closer to 5,000 on top. So we could go down here looking at the y min, in fact, let's say 4,000 and 6,000. So we'll surround the 5,000 y-intercept. You could try that out, and sometimes that works and you can see a little bit better, but that didn't really help us too much. In fact, what we can do now, and this is one of my favorite things to use that I don't see students use very often, watch this one. Zoom box, option number 1. I love this thing. We go over here, see that little cursor right there? And if we just kind of, we're basically going to give it a corner of our screen. So go over here somewhere, hit enter, and now I'm going to go down and go right. Now you see this little box that it's creating? That is going to zoom in just on that one tiny little spot of our graph. So once I hit enter, look at that. Oh, that looks pretty good. Now I can almost see how there's a minimum and then it's going back up and then there's a maximum. So again, I could do another zoom box if I needed. In fact, maybe I'll do that just to make it very, very clear what I am talking about here. So let's go enter here, go up, come over here, and then it's gonna be obvious that there's a min and a maximum inside this thing. And back up, very good. Now we can see it. There's a min, there's a max. So with that, that's how we play around with getting some closer and closer screenshots of how to make this fit to see our mins and maxes. So then we would just write in. Now, if you had a problem where we need to write in that window, then we'd go here, and you could round this off. It doesn't need to be, exact on that. Whoops. Let's pull that min and max over. So we could round off, and let's just say the x min, we could go with -1. The max, we could just go with 1. The x scale, yeah, just 1, doesn't really matter. And then the y min, 4,975, and the y max, 5020. Again, we're just kind of rounding off to some nice numbers that we could put in here. Doesn't need to be these crazy decimals. And then that's a window that would work. You could see the mins and maxes. Beautiful. What's up next in our lesson? You've heard of extreme sports before, but have you ever heard of Extrema Sportsa? Here, take a look at this. You didn't know the Algebros were so into surfing like that. Isn't that great? See, get that? Our lesson's on Extrema, so we're doing Extrema Sports. Okay, moving on. Now we're going to come to the function analysis where we put everything together. This is the fun part. We're going to look at all of these different things that we have in the table below. So the first step is to figure out the domain. The domain is going to be where the denominator does not equal 0. Which we have no denominator, so we don't need to worry about that. And then the other part of it is a radical. So we're going to take this radical here, 4 minus x. Whatever's under the radical must be greater than or equal to 0. And when we solve this, greater than or equal to -4, we get x is less than or equal to 4. Okay, there's our domain. So the graph's only going to exist when x is less than or equal to 4. Then we have vertical asymptotes. With this one, we have none. There's no vertical asymptotes because there are no denominators in this, no variables in the denominator, I should say. And then with wholes, again, nothing's going to cancel, so we don't have to worry about this. This goes back to our last lesson then. So you want to kind of list these things out. You have to use just what we did in our last lesson using the equation that we get. Now, before we start listing the maximum and minimum values, local, absolute, all that stuff, increasing, decreasing, let's jump to the graph. So I'm going to jump ahead here and plug into a calculator. So grab your calculator and let's plug this in. Delete this. Okay, there I have mine entered. And if we plug this in and graph it, let's take a look at this thing. What's it going to look like? Okay, so I have a standard window, Zoom 6. So let's drag this over here just so we can kind of take a look at what in the world is happening. Now, we said that the domain, remember the domain is that x has to be less than or equal to 4. If we come out here, 1, 2, 3, 4, this is kind of weird. Like, what's going on here? There's a gap in the graph. You have to be very careful on these graphs. This graph actually comes all the way down here, and you can't see it. See this part, it's very, very sharp, and the calculator can't handle it because it's so sharp that there's not enough pixels in here to draw a line that's almost a straight up and down line, and so it just has a gap in the graph. So when you do this, make sure you think about, all right, if I plugged in a 4 here at the end point of our domain, so the end of the domain, what's happening? Plug in the 4, this is 0, the whole thing cancels, and you'd get a coordinate point of 4, 0, an xy coordinate point. So just remember that right there. So we'll come out here, 1, 2, 3, 4. We can plug in a dot here to help us out with sketching the graph. Now the next thing we'll do is, let's take our calculator, figure out the max and the min point. So just by going second calculate, oops, the max and min. So I'm going to go ahead and figure those out real quick off camera so I have that, and then we can write those down real quick. Okay, here we have a minimum there and a maximum there. And then, of course, we also have this blue circle dot right there. That would also be a minimum value. So let's come back here and take a look. Absolute max or min value. Well, this graph is going up forever and ever there, so there is no absolute maximum. And this point right there is the lowest point. So the absolute minimum value is 0. It's a y equals 0. Absolute minimum is 0. Local max min values that are not absolute. So any other ones that are not absolute, yeah, we've got a couple of them. We have a local min at 0.996. So let's go back here. We have a local or relative, you could say either one, local min value of, what is it? 0.996. And then we have a local maximum, 5.035. 5.035. And then that was a local, or you could say relative, a local max, or relative max of 5.035. So it's not an x value. Remember, we're talking about a y value if we're just talking about the keyword here, value.
All right, now increasing, decreasing. This helps us out by going back here. So when is it increasing? It is only increasing along this red portion right there while it's going up. So where is that? It's from this x value to this x value. That is where it's increasing. So we'll go 0.063, and this is where we're gonna do the interval notation. So it's increasing from 0. What did I say? 0.637. 0.6, and we can just round to 4. And then it goes until we get to 3.136. 3.136. All right, so again, you can see if I sketch the graph, find the maximum and minimum before I do all this other stuff, it actually will help speed up answering these points. And then when is it decreasing? So it is decreasing on these values. Let me do that in red. It is decreasing from negative infinity until we get to that minimum, and then it is also decreasing from this maximum point until we get to that minimum point. So those parts in red. So that is, I'll just leave this in red, negative infinity, if we use interval notation, negative infinity up until 0.064. So 0.064. And then let's use the union symbol, and it is also happening from 3.136 up until we get to the end of the domain, which was 4. Close parentheses.
Okay, left-hand behavior. So look at the graph. What's it doing as we go way off to the left? It is just going up forever and ever and ever So that means the left end behavior, we go the limit as x approaches negative infinity of the function. That is going to equal, it goes up and up and up, so we say positive infinity. And then the right end behavior, the graph stops. Since it doesn't go over here, there's nothing way off to the right, so we just say that it's not applicable. Something like NA, and then we're good. Not applicable. All right, we got it except for sketching the graph. So now just use the graphing calculator, and you've helped yourself to be able to get some coordinate points. Let's say we have a minimum at pretty much 0, 1. I mean, it's really, really close there. And since it's just a sketch, that's going to be close enough. And then about 3 and 5. So 1, 2, 3, 1, 2, 3, 4, 5. Right about there. Again, this is a sketch. It's okay if the decimals are off a little bit. And then just, and then we have a maximum. And it's coming down here, and it stops. There we go. There is your sketch. So just remember the domain to check that thing.